Right, 2018, Section B, Question 1. The image on the right shows the new pool bag incinerator in Dublin. Figure B1 shows the plan and elevation of a similar structure. A pictorial view of the structure is also shown. Part A is draw the given plan and make a perspective drawing of the structure given the following. The spectator point S is 20 metres from the corner A as shown. The picture plane passes through the corner A. The horizon line is 10 metres above the ground line. The sloping lines on surface B are inclined at an angle of 20 degrees to the horizontal plane. Use auxiliary vanishing points to determine the sloping lines on surface B in the perspective drawn. Okay, so first thing there, scale is 1:200, so that means we have to divide all those measurements by 200. So if it's 5 metres, it's going to be 5,000 millimetres, which divided by 200 gives us 25 millimetres. Okay, so that's our starting point. So we're going to start by starting this off up towards the top of the page. A there now, what's the best way to start this? Yeah, so we'll start by drawing this angle here and setting this up, and we'll go from there, then we can put in our measurements. So I'm going to keep it down here towards the middle of my page, maybe slightly. Don't know how I'll work fitting this on, but we can add a bit onto it if we have to. You'll have no issue in the exam because you'll have a nice big sheet. So it's going to be not only 25. I want the front length of that actually. I don't know it. So what I'm going to do is I'm going to start by setting up that. I'm going to set up my edge up going up here. 18 mil. This pattern's up along there. We want to go back along here, nice and light. 100. And what that does is that gives us this our back edge there. Okay, and from that then we're able to go and put in all our measurements. So we've got 30, which is 15. We've got 50, and we got another 30, which is 3 meters, which is 15. Okay, and we also got a chimney stack out this way here. Now. That's point C there. Wonder how pencil. I must try pencil for the next questions and see how we get on it. Okay, so that's 14 mil out here. 70. Come out to 70. Give me the front of this lad. Here. Start heavying in this. Okay, and I'm going to take the center of this here. This is 25. I'm going to use that then to mark my distances. So yes. So that's the center there and there. That's our corner A there. That's C. And B is the sloping surface. Okay. That's grand. Our spectator is down here. And it's down 20 meters. 20 meters. 20 meters is 20,000 millimeters. So it's going to be down 100. So divide that by 100 is down 100 mil. Is my spectator. I'm going to need another sheet now to put this in. I wonder if I put it up vertical, would I fit it? Yeah, I probably would have. Okay, so look, it is what it is now at this stage. So how do we start by setting this up? Well, what we do is we join our two extreme edges back to our spectator. Bisect the angle. Join it back, and that's our, and then we get our picture plane. Perpendicular to the bisector through point A gives us our picture plane. Okay. Perpendicular lines bisector gives us our picture plane. Parallel to the edges, parallel to the extreme edges from the spectator to hit the picture plane gives us our VP1 position, and likewise same the other 30 degrees from the spectator gives VP2. Okay, now what height is the ground line? The horizon line is 10 meters above. Okay, so parallel to my picture plane, come down here, bring it down. I'm going to keep it low down here to the bottom of the page because I know my ground line is going to be, my starting point is going to be somewhere here. So that's my ground line. Okay, and I'm going to come up 50 mil, which is 10 meters, for my horizon line. Now this is where it gets real handy if you have a adjustable set square, because you can just set up your angle here for bringing down all your points. So that's my VP1 on my horizon line. That's my VP2 there on my horizon line. 2 VP1. Okay, so then we are set up more or less. Now this isn't the most trickiest thing in the world once we have all the correct skills. Once we have all the everything right, it's not the hardest thing in the world. Okay, so we're going to start by we have our edge of our corners going through point A, our picture plane, so we can just bring that straight down to the ground. Okay, and we can measure up. It's 5 meters in height on the drawing, so that gives us 25 mil on our drawing. Okay, and that is flat on the ground this way, so it's going to vanish back here. It's also going to vanish back over to the edge here. Have you seen? Yeah, because they're flat. This edge here is flat on the ground, that edge there is flat on the ground. And what we do then is we join that edge back to the corner, which is already back to the spectator through the picture plane, and where it hits the picture plane then we bring down parallel. That gives that edge there. Same on this side. We bring that down. Or it hits the ground there. Sorry, not there, because we join it back to the spectator. Everything, all our lines come from the picture plane. So where it hits the picture plane, bring it down. Where it hits the base, there it is. Okay, same then back to the VP2. That's going to come across the VP2, and that's the front of it there, because that line there is horizontal, or is perpendicular to the ground. Okay, that's flat there. And this edge here is fine. Now, this edge here then is different, because what it's doing is it's going back up at an angle, and we're not given a height over here for it, so we don't know how high it's going up, so it's going back up at an angle. What angle is it going back up at? Well, it tells us here the sloping lines on surface B are inclined at an angle of 20 degrees to the horizontal plane. So that means these here are at 20 degrees to the horizontal plane, so they're 20 degrees to the horizontal. Okay, so what we need to do is we need to set up, it's still sloping back this way, so what we need to do is we need to get an auxiliary vanishing point. Okay, an auxiliary vanishing point is a vanishing point shown. A vanishing point is either going to be above VP1 or it's going to be below VP1 dependent. So for argument's sake, this edge here is represented as this edge, and it's this edge. So when it's flat, it's this edge, and then as angles up, it's this edge. But they're both parallel, or they're both the same line in your plan view. So that means they're going to be on the same vanishing point. Okay, so what I need to do is I need to take okay, they're both sloping back there, so I need to set up a line, an angle here that is 20 degrees here to show this height. Okay, so what I'm going to do is I'm going to set up an angle out here of 20 degrees. I'm going to extend it off up. Okay, I'm going to go perpendicular to that then, where it cuts my picture plane, out there to give me a height. So it's that height there. I'm going to call it H. That height there is the height that the auxiliary vanishing point is either above or below the point. Now if I have it below here and I vanish it back there, it's going to be sloping down this way, whereas I know it's above it here, because if I vanish it up, it's going up there. So that's my AUX VP1. So my line is going to vanish back up along there, and that gives me that height there. Okay. So that is that line vanishing back up there. Okay, so sorry about it cutting off there again. So then what I need to do is I need to find this edge here. So this edge here. So how am I going to find that edge? How do I find that point? Well, if what I can do is I'm going to extend it. Okay. If I extend this point out to hit my edge there, okay, I join that back to the picture plane, or back to the spectator, go perpendicular to the picture plane, down through the edge, that point there is that point there. Okay, so if I have that point now, what I can do is I can join that back to my VP2, and that gives me my line running across there. So that's giving me that front line there. Okay, once I have that, then I'm in business. I can go back, then I can find my other edges. So I'm looking for this edge, I bring it down to my picture plane. Where it hits my picture plane, I bring it down. There's the start of it there. Do the same to the other side to find the finish of it. Bring it down to my spectator, where it cuts the picture plane. Bring it down. And there's the other pointer. So there's those two edges there. Okay. This side edge here is sloping back up to VP1. So I can run that back up to VP1. And this edge at the back here is flat, so that can come across to VP2 there. So that gives me then is that'll give me where that finishes up there. Okay. Obviously we've got 3 vertical edges here then. What height are those at? They're at 10 meters, or they're 15 meters in total from the ground. So what I need to do is I need to measure up 15 on a height line. So I'm going to extend this out here to hit the picture plane. I'm going to bring it down perpendicular to hit the ground line. I can measure only off height lines. So it's going to be 15, which is 75. That's the height there. That goes back to VP2. And that's my height then on my front edge here. Here and here. That closes off to there. This is going to vanish back down to my VP1 because it's a horizontal line down there. And this is going to come back up perpendicular there, perpendicular to picture plane. And there we go. Last one then is this edge obviously vanishes back up to the auxiliary vanishing point. And that gives me that last edge there. Okay. That one isn't too bad. The tricky bit here is getting this point. So by extending it, drawing it on there and find it, the rest of it then isn't too bad, if you understand it. Then the height line, obviously just make sure that's the height line, so when you do that height, it's for the front 2 edges, not that back edge. If you want that back edge, you'd bring it down here on the height line, measure it up, and then bring it back, and you'd get that point as well. Okay, you just need to be careful with those height lines. Question B here then is a vertical chimney located at position C. Position C. It has a height of 20 meters. Draw the chimney in the perspective view. Okay. What are they looking for us to do here? It's 20 meters high and they're looking for us to draw in the chimney stack. Okay. So we're actually going to be doing that there now. Actually, we're going to be extending this down to hit my picture plan. I am going perpendicular to the picture plane, down to hit the ground line. Slightly running off the sheet here. Okay. The height of it is 20 meters. So if the height of it is 20 meters, that means it's 100, or 20 meters, it's 100 millimeters on us here. So 100 millimeters. So that's the height of my tower. And then they just vanish back to my vanishing point here. Vanishing point here. Last thing to do then is bring it down to the spectator, where it cuts the picture plane parallel, and then it's in there between them. Yep, it's just in there between this line here. Oh, I don't know. Parallel through the picture plane. It's in between them there. So that's my tower C then. The last thing I want us to do there then is to determine the angle of elevation when viewing the top of the chimney from point S. Determine the angle of elevation when viewing the chimney from point S. So I'm standing here and I want to know what height the chimney is at. The angle of elevation. Okay, so what's to say about my spectator?